Machine learning is hard. Yeah, I said it. And I can already hear some of you going, no way, what's next? You're going to tell me neural networks actually need neurons? But seriously, there's this huge misconception out there, mainly among beginners, who think it's all about importing libraries and calling .fit. You've probably seen those day in the life of a data scientist videos, right? The ones where they spend 20 minutes fine-tuning a model and the rest of the day at fancy coffee shops? Or those influencers promising become an ML engineer in 3 months and make 200K? Yeah, about that. The reason data scientists and ML engineers make 6 figures is because it's not easy, otherwise everyone would do it. Here's the truth bomb. Implementing models is actually the easy part. I know, shocking, right? But think about it. We have amazing libraries like PyTorch and TensorFlow that do most of the heavy lifting. The real challenge? Everything else. Let me break this down for you. Machine learning isn't just about coding models, it's about developing a completely different way of thinking. You need coding, statistical thinking, understanding probability, distributions, and hypothesis testing, problem formulation, knowing how to turn business problems into ML tasks, data understanding because garbage in, garbage out people, model selection rationale because not everything needs a transformer model, business intuition and common sense, because the fanciest model in the world is useless if it doesn't solve a real problem. You need to understand when a simple rule-based system might work better than a neural network, or when the business impact doesn't justify the complexity. And here's what those fancy YouTube tutorials never show you: the hours spent cleaning messy data, the frustration when your model's accuracy is worse than random guessing, those moments at 2 a.m. when you're debugging training failures, the existential crisis when your model works but you don't know why. Let's be real. The tutorials and books can't teach you the mindset. They can't prepare you for the imposter syndrome when you're staring at mathematical notation that looks like hieroglyphics, or the frustration when your model's performance tanks in production. Think of machine learning like being a scientist, which really it is. That's why we call it data science. Would you trust a scientist who only memorized experiment procedures without understanding why they work? Of course not. And look, I keep seeing these posts. Master scikit-learn in a week, or complete PyTorch bootcamp in 10 days. Sure, you might learn the syntax, but that's like saying you're a physicist because you know how to use a laser pointer. A 12-week bootcamp might teach you the tools, but it can't give you the years of intuition and problem-solving experience that make a real ML engineer. Being a data scientist is like being a detective. And actually, most science is a bit like being a detective. Sure, you could memorize every section of the criminal code, every standard procedure, and every step-by-step guide to evidence collection. But what happens when you walk into a crime scene that doesn't match any of your memorized scenarios? What happens when the evidence doesn't fit your textbook cases? A detective who's only memorized procedures will be stuck, while an experienced detective has developed instincts from hundreds of real cases. They know which leads to follow, which patterns matter, and most importantly, why they matter. Let's say you're working on a classification problem and the tutorial covered it like this using scikit-learn. So here's where understanding the principles comes in. You know that? Decision trees split data based on features. Random forests use multiple trees with random subsets. The final prediction is a vote among all trees. Now you can build a simpler version using just NumPy. Create multiple trees using different random samples of your data. Have each tree make decisions based on feature thresholds. Combine their predictions through voting. In cooking, this is like when you can't use eggs in a recipe and need to understand the role they play, binding, structure, and leavening, to find an appropriate substitute. In ML, you need to understand what each component of your model actually does to create alternatives when you can't use the standard tools. This example might seem simple, but you'll encounter this all the time. Situations where you can't use certain optimizers, where your model needs to run faster, where you need to reduce memory usage. Tutorials can't cover every possible constraint. That's why understanding the fundamentals matters more than memorizing the standard solutions. Data science and machine learning need problem-solving skills, which tutorials can't really teach because someone solves the problem for you. You need to encounter your own problems to develop the skill to solve unexpected problems. You kind of know everything, but can't do anything. This often comes from too many tutorials and too little real-life projects. Let's talk about something many of us face: tutorial hell. In ML, it looks something like this: endlessly running Kaggle notebooks, only working with perfectly clean datasets, using default hyperparameters because that's what the tutorial used. Sound familiar? Yeah, I've been there too. The problem isn't the tutorials themselves, they're great for learning. The problem is when you get stuck in this loop of never moving beyond them. I talk about this in my video on how to learn machine learning without wasting time. Go check it out while I wait for you. Done? Okay, for those of you who didn't actually watch that video, let me repeat myself here. To break free of tutorial hell, you need to start working with raw, messy data. Build complete ML pipelines. Understand model internals. And yes, actually deploy something to production. You can start solving a problem with code from a tutorial, but then start breaking it. Start with the clean dataset from the tutorial, but change it for a Kaggle dataset after, and then change it for an even messier, real-world dataset. Change some functions to make it do something specific for your problem. Try to use the code from the tutorial on messy real-world data and figure out where things go wrong and fix them. Really understand what each part of a tutorial and a model does. Maybe adapt the algorithm to another type of problem by changing the loss function or programming your own loss function. Then try to solve a completely new problem without any code from a tutorial. Learn to break down a big problem into its subproblems, then further break those subproblems down to problems that look almost exactly like something you have done before. Find that code, adapt it to that subproblem, then combine all the subproblem solutions to solve your overall problem. It won't work. Fix it, it still won't work. So you fix it again. At some point it will work. So, let's do an example. Let's say I tell you to create a model that predicts customer churn based on their past behavior and transaction data. But we don't even have a column with the target variable. Seems overwhelming, right? Let's break it down. Let's start by looking at our data and defining what churn actually means. Okay, that still seems too complicated, so let's break it down even more. How about just understanding what data we have? Okay, now this is really easy. We just need to look at our data and do some basic exploratory data analysis. We have transaction timestamps, purchase amounts, days between purchases, subscription status, number of customer service tickets, average response time to emails, app usage frequency. Okay, now we understand our data. Next subproblem, how do we define a churned customer? Maybe someone who hasn't made a transaction in 3 months? Great. Now we can create our target variable. And would you look at that? We've solved the first parts of the problem, understanding our data and defining our objective. I'm going to let you finish this because you need to get good at problem solving. You'd need to think about feature engineering, model selection, evaluation metrics. It's even a good idea to practice just explaining what you will do in pseudocode. That someone could be yourself. When planning your project, I do this all the time. Just write down all the steps and break it down further and further until it almost looks like code. This is the type of thinking technical interviews are looking for, so I strongly recommend practicing this skill. Let me give you some concrete tips to help develop your ML mindset, breaking down ML problems. Write down the question you want to answer, at least approximately, but simply and clearly. Start with exploratory data analysis. Define something as a first proxy for your target. It doesn't have to be perfect in the beginning. Build a simple baseline model. Make it super simple. Make it obvious even. Always predict the same class, or always predict the mean. Then start adding some obvious assumptions. Bigger house means more expensive, and so on. Gradually add complexity, add more features, or design your own. Start with the simplest possible algorithms, and only go more complex once this algorithm can't capture the relationships in the data anymore. Focus on one improvement at a time. Make sure you know why you are using which algorithm. To make sure you understand what you are using, pick an ML concept and try to explain it to a complete beginner, maybe a 5-year-old data scientist. Example, try explaining gradient descent without using technical terms. If you can't explain why the model goes down the hill to find the best solution in simple terms, you probably don't fully understand it yourself. Identify gaps in your explanation. Where did you get stuck? What parts were hard to simplify? These are the areas you don't understand well enough. Go back and look at them until you can complete your explanation to the 5-year-old. What's cool is that you guys can now use ChatGPT to explain all of these things to you as a 5-year-old. Us old people had to do it on our own. Project-based learning is crucial. Build real ML pipelines. Use real data and solve actual real-world problems. Work with actual production constraints. Handle data drift. What's data drift? That's when the type of data you get today looks different from the data you had when you first started. Maybe COVID hit in the meantime, and suddenly people buy more online than at the store. Create a portfolio that shows your thinking process. This will help you get a job. Employers aren't impressed with a portfolio full of tutorial projects. They will be impressed with real-life projects solving real problems. Essential ML engineering skills. Let's talk about what you actually need to master. Data skills. Data cleaning isn't just removing nulls. Feature engineering is an art and takes insight into the actual business problem. Data validation means catching data issues before they become model issues. Dataset versioning is non-negotiable. Model development. Algorithm selection based on problem constraints. Start simple and go complex later. Understand what algorithm is meant for what, and make sure you know how to explain it to a 5-year-old. Hyperparameter tuning beyond grid search CV. Cross-validation. That makes sense. Model interpretation because black box isn't good enough. Remember this. Becoming an ML engineer or data scientist isn't about implementing the latest paper from arXiv. It's about developing the intuition and experience to solve real-world problems effectively. The journey is tough, but it's worth it. Focus on building strong foundations, developing practical skills, learning from failures, and most importantly, keeping at it. Don't get discouraged by the complexity. Every expert started as a beginner. Keep pushing forward, keep learning, and don't hesitate to reach out to the community when you need help. If you found this video helpful, share it with someone who might benefit from it too. Like and subscribe for more machine learning and data science content, and check out my other Python and machine learning tutorials on this channel. Your support means everything. Consider backing my work on Patreon to help create more free educational content. You can find the link in the description. Thanks for watching, and may your models never overfit.